That is not helpful.
Yeah.
Alright, I'm going to do the experiment from Joy of Chemistry, demonstration 13. It's on page 189. It's super simple, so I'm just going to do it, and then, well, my kids are going to do it. And then I will give you a couple notes on what happened. Alright, so we have citric acid in a little baggie. We have water. We measured it. It's a cup. And we have a yellow plastic bag. This is not, the color is the bag. It's not the experiment. Okay, Zan said he wants to do water.
No.
So come here.
What? Okay.
I want to do acid.
Alright, so we are going to put...
Water. 1 cup of water.
Okay. Oh wait, Ben, go grab a
Bottle of water.
a regular teaspoon.
What's that?
Is
Is this it?
Okay, so we are going to take the temperature of the water. Rose, are you taking the temperature? No, bigger.
Yes.
All right, come here, take it. Let's find out how cold. Okay, then.
Okay. No, I'm doing it.
Okay, she's coming. No, she's coming. So we have a digital thermometer. It's actually for meat, but it should work. Right now it's reading 70 degrees for our air around us. All right, so step 1.
No, not all the way down. Just halfway down.
What does it say?
65.5.
Is it staying?
It's
Yeah.
staying.
Oh, we lost Taylor. It's 65?
0.5.
Okay, so our temperature... Oh, no, it's not. Oh, yes, it is. Okay, our temperature reads 65.5 on the water.
No,
In the water. Okay, so the directions on this experiment say that we need 2 teaspoons of citric acid. So, see, I think this is 2 teaspoons. It might be more, it might be less. Switch spots with Dan. Alright, so 2
That was a big bug.
here. Make them decent, like full, like a full teaspoon. I think I put 2 teaspoons in. I'm not sure. Okay. So no, in here. Sorry, in the back. 1 and 2. All right. We got 2 teaspoons in. Now, Zan,
the camera.
you are going to put in 1 tablespoon of water. So that's the spoon right there.
1 tablespoon.
We were supposed to measure a cup of water so that the temperature would be good. Okay. So here comes 1 tablespoon of water.
3, 2, 1, go.
All right. Now, come touch the bag.
It's cold. A lot colder.
It's very cold.
It's pretty cold. All right, we're taking the temperature again. Let it
But-
dissolve some more.
This is also that cold. This is not 65.
Okay, we're gonna take the temperature and see what did we get to in this so far.
50, 95.
It's going down. 54, 53. Let me see if I can make it.
It's not.
Wait, hold on. I'm trying to seal it so that we don't lose too much of the gas that's in there. And then, can I make it touch?
Zan.
What?
All right. So here we go. We are at.
Yeah.
We're going down pretty fast. 55. Oh, here we go.
55.
Okay, so I think the lowest temperature was 54 right at the beginning. And this is still cold to the touch. It isn't like an ice pack. Feel it.
That's nice back.
It isn't the same temperature as like an ice pack out of the freezer. But it is decently cold. Like, so this, all you needed was water and citric acid. That's it to get that reaction. Okay, so when it went in, this one required thermal energy. So what's thermal?
Thermometer.
What does the thermometer measure?
Thermal.
Something. Thermometers.
What when you put a thermometer under your tongue when you're sick, what are you trying to find out?
If you have a fever.
Yeah, how do you know if you have a fever?
Degrees.
The degrees, which represents what measurement?
I don't want to be.
Sand.
What are we measuring? You can tell me, guys.
The heat.
The heat, yeah, the amount of heat your body produces. So when this got colder, that means it absorbed the heat energy. That's how this thing gets cold. It has to use the heat. So that's called endothermic. And think of the heat going in, it's not in, but in to the solution that's made. All right, there's another one. I can't do it because I don't have lye. Same process. You take water, but you add lye to it. I didn't bring lye home with me. So you put the lye in the water, but you don't do it in a plastic bag. Because this one is exothermic. The heat is going to exit. So when it exits, it's kind of like the reaction we had at the very beginning of the year when we had our bottle, the bottle pushed, the air pushed the cork out, right? So the gas that was pushing out on that, there was a heat release going on there. So with this one, you don't close the bag when you do it. Instead you do it in a cup of water. So you do a glass of water and slowly put lye in and stir it up. If you have lye, it would be with your tools or with your cleaning materials because it's used to clean out drains. So you slowly add it in and you stir it and you stir it and you can just hold the outside of the cup and you feel it get hot just from that. So that one is exothermic. Okay, so I'm gonna write those two on the board. You guys write it down. Yes, and over here. She tried to give you guys bunny ears on that side. Okay, Ben, can you turn the thing a little? So we have endothermic.